Newton's law. Here's another question. It says a block of mass 1 kilogram, which is this one, is connected to another block of mass 4 kilogram, which is this one here, by a light inextensible string. The system is pulled up a rough surface. That is extremely important. Once they say rough, they are telling you there's a friction. All right, a rough plane incline at 30 degrees, there it is, to the horizontal by means of a constant 40 Newton force, which is this one, which is parallel to the plane as shown in the diagram. All right, and then they say the magnitude of the kinetic friction, like I said, they spoke about rough surface, between the surface and the 4 kilogram block is 10 Newton. There's a friction on this one here, which will oppose motion. The objects are intended to go upwards, so the friction will pull backwards or downwards or down the incline. The coefficient of kinetic friction between the 1 kilogram, this block here, and the surface is 0.2. So you're going to need the fan. So in this one here, even before I can read, they say now, state Newton's third law of motion in words. Some says it this way: action, reaction. That's it. That's the end of the story. Or others, they say, if a force is applied on object A, object A applies an equal force on object B in the opposite direction. That's it. We're done. All right. Now, I don't care about what they're going to say, but here's the idea. Like I say, there is a force here pointing backwards there, which is going to be friction. In this case, it's given for that block. They told me it is 10 Newton. So that's good news. So now, if you focus on each block, one of the things that we are going to do, we are going to show that on a 4 kg, there will be a downward force, vertically downward, which is the force of gravity, which is going to be equals to the 4 multiplied by the 9.8. We're going to take care of that one. And the moment you have that, there will be a force perpendicular to the incline, which is that one there, which is going to be called, some of you, because you love to say this is W perpendicular. Some of us, we love to call it as the force of gravity subscript Y along the Y-axis. Don't worry about that. Then there will be another one that I'm going to put it in green that points in that direction, the green one. So that green one, some of you, you love to call it as W parallel. Some of us, we love to call that one as FG subscript X. It's along the X axis. All right, so we're going to find that. The angle will find itself here. So the 30 degrees will be right there all the time. All right, so now this green one, the formula of it, it's easy to get it. So let's just do that one there. So I'm just shifting this one a little bit there. All right, so now the green one, I want to give its equation because it's opposite. It will always be the force of gravity, this amount here. This one, let's just work out that number, which is that amount. So the green one becomes the 39 force of gravity, 2, and then we're going to multiply it because it's opposite by the sine. It's always sine of 30 degrees. So we can actually times it by sine of 30. It's got to be half of that amount. So which gives us 19.6 Newton. And then the brown one, we're going to work it out. So I'm just making space for that brown one so that we can put the working out there. So this brown one becomes the same thing. It will be 39 rather, comma 2, the force of gravity, but this one takes a cos of 30. Always it will take a cos of 30. I'm going to shift it a little bit more so that I can put the value there. So which is going to be equals to, so we have 39.2 times by cos of 30 degrees. All right, so I'm going to round off to 2. It's 33.95 Newton. Among this, I'm not keeping significant figures. I'm just rounding off. All right. So we are on object 4. But then there's still another force acting on object 4. That force is a tension that's pulling upward there. I'm going to call this one T1. This one I won't even have to call anything. It can be T2. So these are the forces acting on this. You asked me to do a free body diagram of this object, exactly how I indicated these forces. I will draw them as they are. The only thing where there's the block, I'll put a dot because we replace the object with a dot like I did in a previous video. All right, now we focus on the 1 kg. On the 1 kg, there is this force pointing upwards of 40 Newton, and then there is a tension pointing downwards, which is still T1 because it is the same string, and we're going to do exactly the same thing we did like here. We're going to break it into its component. So first, you are going to have a force pointing downwards, which is the force of gravity, which is going to be the mass, which is 1 times 9.8. Well, it just happened it will be 9.8 newtons. All right, then we break that into its component. You're going to have this one here pointing in that direction, and you will have another one pointing in that direction. And where I'm putting a dot, it's where the 30 degrees will be. So now this red one, we know it must be the force of gravity times cos. So I'm just going to call it W, because you call it perpendicular. It's going to be, we need to use, it's the same strategy. No need for me to write that again. So it's 9.8 multiplied by cos of 30 degrees, which gives me 8.49 Newton. And then the blue one, which is going to be W parallel, we're going to use a sign. So it's going to be 9.8 times sine of 30 degrees, which gives us nothing else but 4.9 Newton. Now, we are not done on this one because there is friction. Here, friction was supplied. On this one, what they did, instead of giving us friction, they give it to us indirect. They gave us the coefficients of kinetic friction, which is what I mentioned earlier on, that mu symbol. So we have to find our friction by ourselves. So there is an extra force pointing backwards there, that red one. So to get that friction, it will be friction equals to, I'm using the fan, the mu, we know it. It's 0.29. So it's going to be 0.29. You want to multiply it by the normal force. Now, what I did not indicate in both the object was the normal force. Now, here we go. Here there will be a normal force here. Let's call it N. And also here there will be a normal force there, which is the N. So we save that for last. So when you look at that normal force, it's opposite to the red. This red here, the one that is 8,49. So therefore it will be equals to 8,49. So I'm going to put 8,49 here. So which means times by 8,49 to give me the normal force. So we're having 0,29 times 8,49. We get an answer of, we're getting some values there, which is 2,4621. All right, so if I was interested in the normal force of this one here, it will be opposite to this brown one, opposite to the brown one, which is 33,95. So this will going to be 33,95 Newton. So now I have indicated all the forces acting on an object. Now, here's another thing. Another thing that we need to know is to understand that the object will be moving upward in that direction. So that will be the direction of your acceleration. So that will be the acceleration. So let me shift that arrow there so that you'll be able to see your value. So meaning upward forces minus downwards. You're only going to take the forces along the incline because that's where it's moving. Then we'll be able to answer anything that they're going to ask. So even this time, I'm going to ignore the question. I'm going to do like how we did here. We apply net force, which is that, and we apply the mu if we can. So now I'm going to look at the first object, which is the 41, the 1 kg with the 40 Newton. So the upward force will be the 40, this one, minus this blue down here, this blue here, and then minus that blue there, and minus that red. So there are 1, 2, 3 pointing downwards. So which means for the first object, so I'm going to do net force, it will be upward force, which is the 40 Newton, minus the first one, it will be that friction, which is 246. Let's put that friction there. Sorry about that. Minus 24621 minus the other one was that T1, of which is like we do not know it yet. T1, yes, it's 2 comma, yeah, and then we also subtract this one, which is 4.9. So minus 4.9. All of that by now we know all of that stand for F net. Okay, it must be equals to M A. We already know what the mass is, 1 times the acceleration. I can just put it as just A or put a 1 there, but no need to. The second one, let's verify we didn't miss anything. 1, 2, 3, 4. All right. For this one here, the 4 kg will take the upwards one, which is tension 1. So it's going to be T1 minus everything that's pointing to the bottom, this green one here, which gives you 19.6. So minus 19.6 minus the other downwards here, the friction, that one, which is 10. Then I double check if there's another one. As far as we're concerned, it looks like there's no other. Equals to MA, the mass is 4. So equals to 4, and then multiply by the A. So according to the mathematicians, here we've got equation number 1, and then this one will be equation number 2. All right, now we can now solve for one of the equations. we can solve for t from the yellow one and substitute it there. So let me use the yellow one this time. So I'm going to write according to the mathematicians from, just to bring your attention which one I'm using. So from number 2, my t subscript 1 tension, it's going to be, when we subtract these numbers, let's work them on, negative 19.6 minus 10 goes to the other side. You're going to have 4a plus 29.6. It's that negative 19.6 and a minus 10. All right, so all of that, this thing needs to go here in tension 1, but I must put them in a bracket because that minus will affect the sign of 4a, the sign of 29.6, but I'm going to do it already changed. So now I do the substitution. Now I've got 14 minus 2,4621 minus, already changed, 4a minus 29,6 minus 4.9 equals to a, acceleration. So I'm going to take this, goes that side. You can see with your eyes it's going to be 5a. Then I'm going to add all these numbers together. Let's do that. We come up with this number. You can verify that. Then we divide both sides by 5 to get the a. When I do that, my a is going to be equals to, I'm going to round off to 2 decimal places. It's going to be 0.61 meters per second squared. And I'm going to say up the incline, not up to the sky, up. I'll just say up incline, because you already know, at an angle of that 30 degrees. Now I've got that. So according to mathematician, I can take my 0.61, substitute it into this equation that would have been called the third equation to get my tension. So I'll say T subscript 1 equals to 4, open the brackets. I go substitute 0.61, then I'm going to close the brackets, and then plus 29.6, and then therefore T subscript 1 will be, right, so we get 32.04 newtons, because that is a tension. Let's see what the question says now. All right. The question says, draw a label-free body diagram showing all the forces acting on a 1 kilogram. You see, the examiner always asks you for 1 kilogram, and I told you the idea is to do for all the blocks. Always do it for all the blocks, because what's coming, you can't do it without having done all the blocks. The next question says, calculate the magnitude of the kinetic friction force. Kinetic friction force of the 1 kg block. We got it, which was that red one, which ended up to be 2,4621 Newton. All right, and then the next thing, it says calculate what? The tension in the string. That tension we did. We found the tension, but can you see they didn't even say anything about acceleration? You had to find the acceleration in order to get it, or you could have find the acceleration later. It's possible to find tension first, depending which one I'm solving. I solved for T1 here. I could have solved for A, get the tension without knowing the acceleration. So I always do both acceleration and the tension, because that's how the question goes. Thank you.